Welcome, everyone, and thank you for joining us today. My name is Paul Donahue, and I will be your host. We ask that you please keep your device muted during the session, and if you have questions, please direct them to me via the chat function. We'll do our best to answer questions at the end and to follow up with any unanswered questions via email. As I think you all know, these Tech Talks have been designed to provide straightforward insights into radio frequency components, the related technology, and the design and engineering value that is added by a custom manufacturer such as Quantic TRM. Today's Tech Talk focuses on passive component applications for spacecraft. To share the details, I am once again pleased to introduce Quantic TRM's Chief Technology Officer, Shaun Moore. The author of 2 U.S. patents and a number of white papers and technical articles on passive microwave technologies, Shaun has been with the company since the late 90s, and his passion has only increased over the years, especially when it comes to solving our customers' design and engineering challenges. So welcome, Shaun. Can you share an overview of today's session?
Yeah, thank you, Paul. Happy to. Basically, what we like to talk about today are applications that could include products like TRM designs and manufacturers. So that's really passive microwave components. What we're going to do is we're going to go into some applications, places where we have been successful in designing and building parts for spacecraft. We'll talk a little bit about our overall space heritage, and then have some really what differentiates TRM over some of our other competitors, and then we'll wrap it up with a summary.
Okay, that sounds great. And maybe to get started, what are some of the typical applications?
Yeah, so one area that we've really had a lot of work in is distribution networks for LO signal distributions, as well as clock distribution networks. So basically on satellites, you have to think about them, and at one level, you can think about them actually as being a data relay point, in which case data comes up to the satellite, it gets up and down converted, and then gets shot back down again as part of this relay. In this case, there are 2 functions that are critical for having this relay function properly. One is the clock signal, which means that the entire satellite needs to be synchronized with itself and with the ground station in order for this communication to be effective. So basically, each device in each up and down converter on the satellite needs to be synchronized. So therefore, there are power distribution networks coming from the clock local oscillators, where we have to take that signal and divide it out, and then have it go to each one of those subsystems. So really, what we're looking at here is a multiple input, multiple output power divider or power divider network to be able to accomplish this. Very similar to the clock signal is the up and down converters, where we need local oscillators that are at various frequencies. Most clock distribution systems, to back up for a second, tend to run 50 megahertz, 10 megahertz in that region, as far as to how they actually operate. So it's a fairly low frequency sort of a signal. The local oscillators, on the other hand, for the up and down converters, can range anywhere from L-band, S-band, C-band, X-band, right on up through KU, is what we've seen as a signal that needs to be generated and then split out amongst all of the up and down converters. Now, most satellites, since this is a potential single point failure, really rely on a redundant architecture for the local oscillators. Now, the best way to do that is to have a non-mechanical or non-active component to switch between the redundancy of the oscillators. TRM has built a divider combiner network that is extremely efficient, that also has no moving parts and is completely passive, which makes for a very effective system to be able to switch between local oscillators, as opposed to using a switch, which does have a potential failure mode associated with it. The hybrid approach that TRM has taken is very robust, very reliable, and therefore a lot of customers like that approach because it increases the overall reliability of the system. But here we're looking at really taking a single source or multiple sources of local oscillators or clock signals and distribute them out across to a variety of various components, whether we're talking about up or down converters or as well as clocking devices for synchronizing some other data applications.
Now, I've also heard you speak about signal routing. Would that also be an application for spacecraft?
Yeah, absolutely. So if we're looking at the previously mentioned parts, we're looking about distribution for a specific part of the subsystem where we're looking at routing to between local oscillators and their associated components. Anytime that you have to run a signal from one module to another, you need a power divider or you need a coupler if you need to sample some energy back for some sort of a leveling loop network, right? Any of these sorts of devices. And a conventional sort of power divider or directional coupler or 0-180 hybrid is very useful and is very often needed for these sorts of applications. So these are the building blocks that can go in really in between any of the other major modules that you may have on the spacecraft. And they could take on any number of forms. Sometimes some of these do, like the local oscillator platforms, have multiple inputs and multiple outputs. Other ones have single inputs with multiple outputs, or being used as a combiner where we have multiple inputs and a single output. All of these combinations are something that happens with your typical intermodule signal routing application. And really, I think that this is a part that we really can excel at, is building these sorts of components.
Now, how about antennas?
Sure. Now, antenna feed networks are another big piece as far as to what signal routing is. So we have to route the signal from the either between the aperture itself and back to the transmitter or back to the receiver, depending on whether it's an uplink or a downlink. So things like phased arrays require very large signal distribution networks so that we can actually go in there and have the proper excitation of the phased array. Tracking antennas very often have a mechanical piece on it, and they are often fed with a monopulse type feed network. Really, the exact nature of the feed network really depends on the nature of the antenna itself, but there is almost always a passive distribution system between your transmitter receiver and your antenna system. And again, that is another big place where TRM can add value.
And Shaun, are there also communication-related applications?
Sure. So if we're looking at communication between either the satellite or the launch vehicle, there's a lot of data, and very often the data is termed as telemetry data. This very often is communicated through some very rather simple conformal antennas mounted on either side of the launch vehicle, and you want to have a uniform excitation of these things. So depending on the exact nature of the antennas that you're putting on, you're either going to want to have a power divider or possibly a 0-180 hybrid feeding those antenna networks. So this is another place where TRM has built and designed quite a few parts in the past to be able to go in there and be able to divide this signal and have it out to a very simple antenna array used for data communications between the launch vehicle and the ground systems, and be able to supply that very important data link and all of that data of the launch vehicle as it's being launched. So there, again, a lot of really good applications going on here, and for some relatively simple parts, but again, very critical parts to the system to make sure that the data does get from its unit out to the apertures and back down to the ground again.
Okay, fine. So I wondered if you could share some insights on Quantic TRM's experience in designing and manufacturing for spacecraft.
Sure. So Quantic TRM has been building parts for spacecraft since 1999. So at this point in time, we are getting close to 24 years of space heritage. There is a large amount of learning that has happened over the years in designing parts for that environment. And also understanding about what is really important for that environment versus what's kind of a nice to have. Part of what we really have focused on is as part of our space heritage has to do with things like material selection, specifically for outgassing on very specific sorts of spacecraft, multi-paction and critical pressure corona breakdown are two failure modes that tend to be fairly unique for either high altitude vehicles or spacecraft themselves. At this point, TRM has extensive experience in designing and mitigating for those sorts of failure modes. In addition to doing all of the additional testing and screening that is very much involved with these high-rel parts, and also things that are unique to the space environment. Things like thermal back testing are things that again are unique to parts for spacecraft. And these are parts that these are designs that we have good experience with and good heritage with. And based on that heritage, we will design parts that really won't have any problems at all in surviving these environments. And then being successful with whatever your needs actually are. And also we've done enough designs at this point to understand what tailoring needs to happen in order to meet all these requirements, and something I think that we've been quite successful with, and will continue to be successful with based on our extensive knowledge and heritage.
Well, great information as usual. And finally, in addition to the company's successful track record, what are some of the unique aspects or differentiators that Quantic TRM brings to the table when it comes to space applications?
Sure. So basically, a big piece of Quantic TRM is that we want to work with our customers. We want to make sure that our customers are successful, because if our customers are successful, that means that we can be successful. And basically, what we like to do is go out and speak to our customers, find out what their application is, so we can work together to make sure that we have the best possible solution for that particular need. There is no one best solution for every sort of opportunity or problem to be solved. Quantic TRM recognizes that, and really we want to work with our customers to make sure that our customers do get the absolute best technical solution as far to meet those needs. We do that actually by being knowledgeable with how we select our designs, how we develop and have our packaging, making sure that the designs will meet all the environments. And also, we're very happy to provide the testing and objective evidence that our parts do meet those requirements. And the bottom line here is that Quantic TRM is a solution provider. Really mean that what we are looking at doing here is providing the total solution that our customers need for their individual project. We are not simply a parts provider. If the system requires more than that, whether it be analysis or testing, again, we are configured and we are happy to provide those services as well.
Well, excellent. And we'll share just a little bit more on how people can access those services in a minute. But in the meantime, we have time for at least one question. And one that we have received is very simple, I guess, but are these the only applications for passive components for space application?
Absolutely not. Basically, if you can imagine every place on a satellite or a spacecraft or a launch vehicle where an RF signal needs to get modified, sampled, or divided, that is an opportunity for TRM to supply products. Its potential applications are far and wide. Basically, every time that we have an interconnection on the system, that's an opportunity for TRM or for a passive product to be in the system, whether it's between modules, on and also within a module, very often between various subsystem groups. If there's an amplifier that needs a leveling loop, well, you're going to need a directional coupler for that leveling loop, or whether or not you're dealing with something else that is actually on a PCB. TRM can supply a surface mounted component to allow that good high quality connection to happen at a surface mount level. It's not just connectorized parts. So with that being said, the imagination is really the limit as far as where we can go for passive components on spacecraft.
Excellent. Well, thank you again, Shaun, and thank you everyone for joining us. If you are a customer and have more questions, or if you'd like to discuss details with one of our engineers, as Shaun talked about, we'd love to hear from you. Please feel free to call the engineering hotline. The number is on your screen, 888-677-6877. There are no costs for these calls. If you're one of our field sales representatives, then you know your calls are always welcome too. And you can also submit questions directly through the sales rep portal on our website. If, in case it's helpful, we will be publishing a list of the next 6 Tech Talks beginning in January. Thank you. Thanks again, Shaun.
Thank you, Paul.